force of friction. I'm sorry. Alright, to figure this out, the distance at which the maximum velocity of the pellet can be calculated by comparing the forces of friction and the force exerted by the spring. And we'll call this distance little l. So our formula will be force of friction, the force of the spring is equal to the force of friction. So in this case it would be negative KL is equal to the force of friction. And our K is our spring constant, which is given in the problem. And then we're solving for little l, which is equal to the force of friction. Problem, we can substitute the spring constant for 15 newtons per meter for K, and the force of friction on the pellet, which is negative 0.074 newtons for F of friction, in the equation to solve for our little l. And so to do that, we would do our negative 15 L is equal to a negative 0.074 newtons. And we'll clean up the equation by rearranging it. And let's enter this into our calculator. So our little l is equal to 0.493 centimeters. Now, so therefore the distance at which the velocity is maximized is given as a formula. The best way to describe it would be the distance is equal to change in x minus L. And based on the problem, we know that the compression of the spring, or the delta x, is equal to 6 centimeters. So, and we know that D, so then therefore if we plug in our givens, our distance, delta x is going to be our 6 centimeters minus our 0.493 centimeters, which ends up giving us 5.50 centimeters. So the maximum velocity of the pellet would be at 5.5 centimeters from the starting position. For part B is what is the maximum speed achieved by the pellet as it is fired from the gun. So for that, we need to convert that potential energy into kinetic energy. So we would use the formula 1/2 mv max squared is equal to 1/2 kinetic distance squared. So we want to rearrange this to make it easier. So V max is going to equal to the square root of kd squared over m. We can substitute the mass of the pellet for 25 grams for m, spring constant of 15 newtons per meter for k, and the distance at which the maximum velocity 5.5 centimeters for d to solve the equation. So to do that, we would do square root of 15 of m times 5.50 centimeters squared over our 25 grams. Then we will continue on 15 meters. Centimeters. Squared over 125 grams, 10 to the negative 3 kilograms over grams. Alright, and when we enter that into our calculator, we come out with 1.34 meters per second. And that concludes this problem. We're not going to do part C because it'd be too long. Originally I wanted to make this assessment 8 and 9 combined, but there's just not enough time to keep it within 5 minutes. So hopefully you enjoyed it. This is Michael Diamond, and this is assessment number 8.